Studies on performance characteristics of warm recycled asphalt mixes. Abstract: Recycling of asphalt pavement materials and incorporation of warm mix asphalt, WMA, technology are the two methods adopted for recycling existing pavements and also to reduce carbon emission. The quality of reclaimed asphalt pavement, RAP, materials depends on its age, as the material rheology plays the prominent role. Studies were carried out on two different aged RAP materials, viz., 8 years and 12 years using VG30 binder. The RAP materials were blended at varying proportions of 10, 20, and 30% for SMA mixes. Zycotherm is used as warm mix additive. Recovered binder and VG30 with warm mix additive were characterized by complex modulus test. Mix design was carried out by Marshall method to determine stability and optimum binder content, OBC. The RAP Warm SMA mixes were tested for its indirect tensile strength, ITS, and rutting resistance. The binder rutting properties G/sin improved with increase in RAP content and fatigue parameter G/sin decreased with increase in RAP age and its percentage. Based on performance tests conducted, it is observed that 12 years aged RAP indicated better resistance to rutting when compared to 8 years RAP binder. Similarly, mixes prepared using WMA additives indicated better resistance to moisture for both 8 and 12 years aged RAP mix. Keywords: warm mix asphalt, stone matrix asphalt, reclaimed asphalt pavement, rutting, ITS. Introduction. Aggregates account to about 97% volume of bituminous mixes. Continuous dependency on new and freshly available materials leads to depletion of natural resources. Thus this can be reduced by adopting recycling techniques. Varuna et al. 2021. Recycling is a technique of replacing and rehabilitating the pavement structure influenced by the adverse effect of distresses. Using more quantity of RAP in asphalt mix increases stiffness and causes failure of pavements due to fatigue damage. McDaniel and Anderson. 2001, Huang et al. 2004, Daniel et al. 2010 and Martin et al. 2014. However, the studies conducted by Widyudmiko et al. 2008, Al-Qadi et al. 2012, McDaniel et al. 2012, showed that the dynamic modulus of the mix as compared to virgin mixes. The utilization of higher percentage of old RAP materials in bituminous mixes could be achieved by adding a softer grade of bitumen, use of gap-graded mixes, or using warm mix additive. El-Kashef et al. 2018. The addition of warm mix asphalt in stone matrix asphalt mix may be one of the option to incorporate higher amount of RAP content as it contains rich binder with less aging properties to improve durability. The addition of RAP improved fracture resistance of asphalt mixtures at intermediate temperatures and decreased with addition of warm mix asphalt. Singh et al. 2018. Bet et al. 2017, carried out to investigation on the aging properties of low carbon emission mixes. Su et al. 2021, Lee et al. 2021 and Bell et al. 2013, and proposed that WMA technology can be utilized at 20 to 30 degrees Celsius lower than current HMA technology. Use of RAP in the conventional mix reduces the construction cost by 20 to 25%. Use of SMA has reduced rutting by 30 to 40% and increased moisture susceptibility with WMA additive. Guidelines are developed for using maximum RAP content. However, RAP gradation and RAP binder quality are the major concern in adopting appropriate quantity of RAP in construction. Hence in this study, an attempt is made to determine amount of RAP that can be utilized for SMA mixes with focus on mix performance using WMA technology. 2. Scope and objectives of the present study. The scope of the study is to assess the effect of RAP material in SMA mix using warm mix asphalt as an additive. An attempt is made to find the influence of WMA on RAP materials with varied age of 8 and 12 years. 3. Experimental work. A. Materials and mix. The conventional crushed aggregates used for preparation of specimen were collected from the nearby crushing plant. The RAP materials of having the age of 8 and 12 years were collected from various locations across the state of Karnataka. India. VG30 is used as binder and 0.2% Zycotherm is used as warm mix additive. The representative sample of conventional and recovered binder was extracted by centrifuge method and later tested for basic properties. Complex modulus of binder I.E-rutting and fatigue cracking parameters were determined and results are presented in Table I. The gradation adopted for SMA binder layer is as per IRC SP 79/2008 and is shown in Figure 1. Marshall mix design was carried out as per Asphalt Institute 6th edition, MS2. The SMA mix was prepared using 10, 20, and 30% of RAP materials. Performance studies on the above mixes were carried out by conducting indirect tensile strength and rutting studies. B. Marshall mix design. Marshall mix design was carried out on conventional and RAP mixes as per ASTM D6927. Marshall specimens were prepared for SMA mixes by incorporating RAP at proportions of 10%, 20%, and 30% using VG30 with bitumen contents of 5%, 5.5%, 6% and 6.5%. The mixing and compaction temperature adopted for warm SMA specimens for Marshall tests is 130 and 110 degrees Celsius. IRC SP 79:2008 suggests minimum optimum binder content for SMA mixes to be 5.8%. Marshall properties at different binder contents and at optimum binder content for different SMA mixes are presented in Table 2. See Indirect tensile strength tests. Moisture resistance of SMA mixes was evaluated by performing indirect tensile strength test as per OSHTO T283 at 7% air voids content. A compressive load was applied on cylindrical specimens at a rate of 5 cm/min and the failure load for the specimen was noted. Moisture sensitivity was determined by determining tensile strength ratio as per IRC SP 79:2008 on Marshall specimens. The conditioned and unconditioned specimens were tested for its and TSR is calculated using equation, where S1 equals unconditioned samples tensile strength, kPa. S2 equals conditioned samples tensile strength, kPa. As per IRC SP 79-2008, the minimum TSR percentage for SMA mixes should be 85 and the results of its test are shown in Fig 2. De-Rutting Studies. The behavior of SMA mixes to permanent deformation was assessed by conducting rutting test at 60 degrees Celsius. Slab specimen of dimensions 600 mm x 200 mm x 50 mm is conducted at 60 degree using immersion wheel tracking machine. The deformation was recorded for 10,000 cycles for tire pressure of 7 kg/cm2. For results and discussions. A. Rheological properties. The binder rheological properties were evaluated by conducting rutting and fatigue parameter at 25 and 60 degree respectively. The binder rutting parameter, G/sin, D, should be more than 1.0 kPa and 2.2 kPa for unaged and aged binder samples. Likewise fatigue parameter, G.sin, D, should be less than 5000 kPa for aged binder. From Table I, it is observed that the binder rutting parameter improved with increase in RAP age and percentage due to increase in stiffness of binder. The decrease in rutting by addition of warm mix additive is due to increase in viscosity of binder. However, G*/sin values are within the permissible limit, 2.2 kPa. Similarly, from Table I, the fatigue parameter G*sin increased within RAP age and percentage indicating possibility of fatigue cracking due to stiffening of binder. All the mixes except 12 years aged mix with 30% RAP failed to meet criteria. However, 5 years aged RAP of all combinations exhibited better resistance to fatigue cracking. Similar trend was observed in published literature where fatigue cracking of mixes was decreased with the addition of WMA additive to hot asphalt mixtures containing different RAP percentages, Singh et al. 2018 and Liu et al. 2009. B. Marshall properties. The OBC instability was determined for varied age and percentages of RAP. From Table 2, the following observations were made. Optimum binder content increases with increase in age of RAP from 5 to 12 years, indicating more amount of bitumen is required to prepare SMA mix. However, the stability of the mix increased with increase in age of the RAP indicating better strength of the mix. See Indirect tensile strength ratio. IRC SP 79:2008 recommends that TSR percentage should be more than 85% for SMA mixes. From Fig 2, it is observed that all the mixes satisfy the requirements of Indian Roads Congress. However, the mixes prepared using WMA additive indicated better resistance to moisture compared to mixes prepared without WMA. This may be due to the coating of WMA additive around the aggregates and acts as anti-stripping agent. De-Rutting Test. The test was conducted for 10,000 wheel passes, and the final deformation is presented in Table 3. It is observed that SMA mixes prepared using WMA additive showed more deformation compared to mixes prepared without WMA. This may due to addition of WMA additive makes mix less aging, thereby less stiffness and more deformation. Likewise, it is also observed that addition of RAP content increased rutting susceptibility of mix. RAP mix of 12 years aged showed better resistance to rutting when compared to conventional and 8 years aged RAP material. V. Conclusions. The following conclusions were drawn from present study. Binder rutting property increased with RAP content and resistance to fatigue cracking decreased. However, 12 years aged mix having 30% RAP content will be prone to fatigue cracking as it fails to meet the requirements. Therefore, it may be necessary to rejuvenate the binder or use softer binder if the percentage or age exceeds the mentioned limits. Optimum binder content increased with increase in age and RAP percentage. For WMA mixes, the amount of binder required is less compared to mixes prepared without WMA additive. WMA mixes showed better resistance to moisture for all combinations of SMA mixes compared to mixes prepared without WMA additive. Addition of RAP in SMA mixes showed better resistance to rutting due to increased stiffness of mix. SMA mix having 12 years aged with 30% RAP content showed better resistance to deformation compared to 8 years aged RAP mix. Thus, integrating warm mix technology and RAP materials in gap-graded asphalt mixes may be a step towards durable and sustainable pavements. Acknowledgement. The authors declare there is no financial assistance or personal relationship that appeared to influence the work reported in this research article.